Enough.
No.
All right, guys, we are doing the notes on page 25. So there's a couple pages that go with this. So we're moving away from triangle congruence, and we're talking about actual relationships within a triangle. So the first thing we talk about is having perimeter. Do you remember that perimeter is the distance around the edge of a polygon? And if it's a circle, we call that circumference. So we're talking about the perimeter, and they're telling us the perimeter is 47. So honestly, to find the perimeter, we would just add up the lengths of the three sides. So if I know that the perimeter is 47, and I know that these three sides are here, I would just go through and add up like terms. But here's what you're really doing. You're saying this side, 2x plus 6, plus this side, x plus 3, plus the third side, should all come together to equal 47. That's what you're saying. So the 2x plus 6, x plus 3, 3x plus 8 all equal 47. I don't really need the parentheses here. I just want to show you that it's three different sides. So let's add like terms. 2x and 1x, if you will, is 3x plus 3x is 6x. All right, add up your constants, your like terms. Your 6 and 3 is 9, plus 8 should be 17. And that is equal to 47. So if you don't want to write this out, I'm fine with it. Some of you will just walk around the triangle with your eyes and you'll add up the x's, you'll add up the constants, you come up with the same equation, and then we're going to solve it, right? We want to solve for x. Now notice in the direction it says find x, but it also says find the lengths of all three sides. So there's more than just x. Let's subtract 17, right? Cross the line, change the sign. So I have 6x on the left equals 30. Divide out the 6, x equals 5. Okay, so we found x, but we want to find the lengths of three sides. So all I have to do is take that 5 and plug it in. 2 times 5 plus 6, plus 10 plus 6, so this side is 16. This would be 5 plus 3, so this side is 8. And this would be 3 times 5 plus 8. So 15 plus 8, and I should get 23. So x is 5, the three sides are 16, 8, and 23. And the order doesn't matter unless they tell you to list them from least to greatest. Okay, so not bad. Quick warm-up review. Now we're going to get into classifying triangles. Not a hard thing. I think you're familiar with these words. We just have to remember which one's which. So a triangle is a polygon. It has three sides. A square, a rectangle, a pentagon, those are all polygons, but we're more specific. A triangle has three sides. So we can classify them by their angles and by their sides. All right, so first, let's name the sides of triangle ABC. This is old news, that's why it's a recall. So the sides would be side AB, we have side BC, and we have side AC. Those are my three sides. Name the angles. Well, we've got angle A, angle B, and angle C. And you guys are pretty good with that from our triangle congruence, okay? A, B, and C are called the vertices, the corners of the triangle. All right. I know. Ready to flip over?
Yeah. No. Yeah.
Okay. So on the back, three acute. Do you remember what acute means?
Under 90 degrees.
Under 90 degrees. So three acute angles is going to be an overall acute triangle. And guys, we're classifying by angle measures. Okay, so you need to make sure you know the difference. So what makes it acute? Three acute angles. Acute means less than 90 degrees. So make a little note of that. Less than 90 degrees. Okay, if you have three congruent acute angles, it's called equiangular. Looks like equi and then angular. Okay, I should be able to remember that because we have three congruent acute angles, equal angles. Now, do you remember how many degrees are in a triangle?
No.
Well, how many degrees are in a square or a rectangle? Let's do that. Okay, so 180 degrees are in a triangle. So 360 in a square or rectangle because the 490 degrees. A triangle always has 180 degrees inside of it. Okay, 180 degrees inside. So why am I talking about that? If you have three congruent angles, take 180 degrees and divide it into three groups, we get 60. So anytime you have an equiangular triangle, every angle is 60 degrees. Okay? So when it's equiangular, each angle is 60 degrees. Okay, next one. Pretty obvious. We've got a right angle, so guess what this one's called? A right triangle. Who knew? Okay? One right angle means you have one that is exactly 90 degrees. I can only have one 90-degree angle, because if there's 180 degrees and you take off 90, there's only 90 left for these to share. So these angles both have to be acute then. Okay, obtuse, I think of the word like obese, bigger. So obtuse is one angle. All you need is obtuse angle is greater than 90 degrees. You can only have one obtuse angle, because if this angle is 100 degrees, then there's only 80 degrees for these to share. So it's called an obtuse triangle.
Why are we learning about triangles in 11th grade?
Building our geometry skills. All right, so we're going to classify each triangle by angle measure. You want to make sure you listen to the directions there. So look at my angles. They're marked for me. 69, 78, 33. Do you see that they're all under 90 degrees? So we would call this acute. All right, and number two, and you guys have your list on top here. And number two, all three angles are equal. So you can see those little tick marks on there. Equiangular. Equiangular. And just to add, that would mean that all of these angles are 60 degrees every time, because it divides up evenly. All right, I see a right angle, so this must be a right triangle. Acute triangle, equiangular triangle. And then do you see that you only need one angle to be greater than 90? What's this one? Obtuse. Obtuse triangle. Okay, so that's classifying by what we see and what's marked. Now, sometimes you're going to be asked to classify by what it appears as. All right, next we're going to talk about the sides. So if you look at this, this is by side lengths. If you have two congruent sides, we classify that as isosceles, and the spelling is ISOSCELES. I should stop trying to spell.
Mess me up.
I know. ISOS, and then it's Celes. I don't know. Maybe you think it's dumb. I remember that like ice cream cone. Doesn't that look like an upside down ice cream cone? You got the two equal sides, so isosceles, ice cream, whatever it takes. Okay, do you notice I have three congruent sides? This is equilateral. So equal and then lateral, like lats, your sides. Equilateral. I think I might have screwed that up. I think it's equi. It's EQUI, guys, not equal. It's like equilateral. So you might want to fix that. Now, here's the deal, and we're going to talk about this later. If the three sides are equal, you end up having the three angles are equal. So we'll talk about that later, but I wanted to add that in. Okay, if you have no congruent sides, see how nothing is marked congruent? This is called scalene. I don't know. I look at, like, think about it being off the scale, nothing matches, however you need to do it to remember it. Okay, so here's a little note. When you look at a figure, you cannot assume the segments are congruent based on the appearance. They have to be marked as congruent, unless you're told, what do you think it looks like? All right, so it says classify each triangle by its side lengths using the diagram. So first we're going to look at EHF. So I'm going to highlight that. EHF is this triangle. Can you ignore this real quick? What do you notice about this? Now we're going to classify it by side lengths. Do you notice that it has two tick marks? Guys, if that's 10, wouldn't that also be 10? So that would be considered two congruent sides. Look up top, it is an isosceles triangle. Oh, I should go back to bed. There, I got it. Isosceles triangle. Okay, now it wants us to look at triangle EHG. It's the whole big triangle. Do you notice that down here, that's 14? Do you guys see they gave you 10 and 4, 11 and 12? Are any of the sides congruent? Nope. So what do we call it? Scalene triangle. Okay. You think?
Yeah, I saw it.
It doesn't have any congruence, so I agree.
What do you think? You know, like isosceles, where you like equilateral.
Equilateral, yeah. They're the easiest to work with. All right, now we're going to talk about the measure of the angle. So I already alluded to this. So we can classify them. That's a real quick thing, but you want to make sure you differentiate the names for angles and the names for sides. But this is called the Triangle Sum Theorem, okay? So in here it says the sum means add them all up, of a triangle measures of a triangle is, the sum of the angles of measures of triangles 180 degrees. So angle A, the measure of angle A, plus, this is my little m, remember I did that before? Measure of angle A plus the measure of angle B plus the measure of angle C is always going to be 180 degrees. Doesn't matter what type of triangle you have, they always add up to 180. So you're probably going to want your calculator, but you could use your brain. You know, I'm fine with that too. Not today, huh? So it says examples, find the measure of the variables in the triangle. So we're looking for the variables. Guys, this whole thing's 180 degrees. So if I wanted to write an equation, which honestly I'm pretty lazy, I don't normally write the equations, I would take 35. Now this is the angle measure, plus 65 plus A should add up to be 180. So I want to remind you, when we started this, we did the perimeter. The perimeter is the length of the outside, and that could be anything. It has nothing to do with 180. It's the angle measures that are 180. Okay, so you add these up and you take it away. 35 and 65 ends up being, go with 100, plus A equals 180. So sometimes I need to do an equation. This is one time where I don't have to, but I get A is 80 degrees. Now, sometimes you want to go in and put that 80 there because we're going to use it to find something else. Okay, so this is one where honestly, guys, I could have just taken my calculator and done 180 minus 35 minus 65, and I get 80. And that's really what we did. We put these together and we subtracted them. Okay, so look at number 6. They gave me 58. Isn't that 90? Maybe that will help me if I mark it. And there's C. So couldn't I, if I wanted to, just take 180, take away 58, take away 90, and what's left over is C? So you could do it that way.
We have to write this stuff out.
You don't have to. There's going to be times that you're going to need to. So if you have your calculator, you can do it if you're using your brain. I get that C is 32 degrees. But there are going to be times that you have to write it out because you have to build an equation. There's more variables involved. The other problem is if you don't show it and you get it wrong, it can't help you as much with points.
Yeah, I'm not going to write if I get one wrong.
All right, look at number 7. What kind of triangle is this? Do you know?
Equal, whatever.
Well, no, because these two angles are equal, but is this one equal?
No.
No, okay. We're going to talk about this later. This is actually an isosceles triangle. It's one of the properties we'll talk about. If the base angles are congruent, then the sides are congruent. But we don't know that yet. Here's what I know. If I take 180 and I take away the 75, that leaves me 105. Okay, these two angles together add up to 105. So wouldn't I take 105 and divide by 2? So that's one way I can do it. I can zoom in on this. What's 105 divided by 2? 52.5 degrees. So X is 52.5 degrees. Guys, what did I really do? I looked at this. If this is X and this is X, so this is where if I couldn't do that in my head, here's what I know. Just another way to look at this. X plus 75 would equal 180. Do you see that that's 2x plus 75 equals 180? And mathematically, I would then subtract 75 from 180. Do you see that we did that? And then divide by 2. So sometimes we don't need the equation. We can do it in our head. Sometimes we need an equation. Okay, number 8, there is a lot going on over here. There are 2 things that you have to start with. So one of them, do you remember your linear pair? 2 angles form a line. How many degrees do these 2 angles add up to? 180. So to find angle C, take 180 minus 55. What's left?
I just want to get this over with.
Should be 125 degrees for C. Okay, now, there's a couple places you can go. You could figure out D now, or you could figure out B. What do you want to try? I can't figure out A yet. I don't know enough.
No, definitely
D is in dog?
Yeah.
Okay, so do you see the triangle? Do you see that I have 180 degrees? To get D, I'm going to take 180 minus the 32 minus the 125. And whatever's left over is the angle. So take 180, take away the 32, the 125, we should get 23. So there's a couple ways to find these things. All right, I want to jump to B now. I can't get B unless I have A. So I could ignore and look at the big triangle. You got to look at these things differently. See the big triangle? There's 23, there's 90, ignore that 32. There's 90, and then you can find A. So that's one way. Or if this is a 90-degree angle and that's 32, wouldn't that be 90 minus 32? This whole angle is 90. Take away what you know. 90 minus 32, we get that as 58. Now, you can still use your big triangle, or you could focus here. So I could find A another way. 180 minus 55 minus 58. It should be 67 degrees. I love all the calculators being used in here, Mr. Adams. It's amazing.
Don't need them, I guess.
I know. You guys are so smart. All right, let's jump to number 9. Again, you have 2 triangles going on. So first thing, they have a little arrow here. If you can just focus on this triangle, that's really, I can't figure out Y and Z until I know more about here. So looking at this, if that's 62 and that's 15, can't I find X?
Yeah.
Yep, take 180, take away the corner 62, take away the 15. So what is X? Should be 103 degrees. Now I'm going to fill that in because that helps me. How does that help me? Well, here is a line again where we want to use our tools at things we know. Isn't there always 180 degrees on a line?
Yep.
Okay. So this would be 180 minus 103. And that should be what, 77 degrees? All right, well, that helps me because now I can focus on, you could use the big triangle, but I'm just going to use this guy. And I'm going to take Z, I'm going to take my 180 degrees in my triangle, take away 60, take away the 77 we found. And that gives me,
43.
it is 43 degrees. Big brains today, big brains. Okay. So I'm going to pause this, and I'm going to have you try number 10. All right, we were just having a discussion about the magic number of 180 degrees. Guys, we need to break things down, and we need to trace, if it helps you, grab a highlighter, some colored pencils, because sometimes that helps you to differentiate. I don't want to look at the whole big triangle, and how do I know which one to start? This one's only missing one piece. So I'm going to take 180 minus 30 minus 25, and that gives me 125 degrees. Okay, now, do you see that we have a line? So we have that linear pair. So n is going to be found by taking 180 minus the 125, and we should get 55. Do you agree with that? And now that I've gotten to there, I'm going to focus on my little triangle, and to find k, I'm going to take 180 minus 48 minus the 55. So it's almost like a puzzle. You just keep solving the pieces. And this should be 77 degrees. All right. If you wanted to, you could have ignored this and used the full triangle. You would have used the 30 and the two angles down here together, and then the 77. Okay, we have a couple more to try. So this is where you might want to pause the video and try these three on the back.
All right, done.
All right, some of us are done. There's two things you could, think about. This is a linear pair right here. The problem is I can't get F until I get G. Now, we'll talk about this rule later. There is a rule about the remote interior angles. Add these up and you get the sum of that exterior angle, because these two would have to add up to be its supplement. But I don't know that yet, so I'm going to go with what I know. Focus on the inside of the triangle. 180 degrees, take away what we know. What do we get? Inside, we get 48 degrees for G. Okay, then I'm back to that linear pair. So I would take my 180 degrees on a line and take away 48 degrees, and we should get 132. Now, just do me a favor. Add up 61 and 71. What do you get? 132. Guys, if the triangle has a sum of 180 degrees, these two, whatever these add up to, 132 degrees, would have to be, the rest of it to get 180 would be supplementary. So this angle would be add up to get 180. Well, these two are supplementary because it's a line. So if that's 48, that's 132. So that's the relationship, that these are equivalent to this guy when you add them up. Okay, so a little extra there. So this is called an exterior angle. It's on the outside. Inside are called interior. This one, you could either get D or E first. It doesn't matter. So if you're looking at your linear pair, this would be 180 because it's a line minus 39 degrees, and we should get 141 degrees. Okay, I could use that and take away 77 to get E, but since we don't really know that as an official rule, we're going to cover this up and take 180 minus 39 minus 77, and we should get 64 degrees. Okay, one more here. We're going to have to do a little bit more work. So these we could just sort of type in the calculator, just number, and get an answer. This one's a little more effort. So this angle here is 30 degrees. I'm going to mark that. This angle is 48, and this angle we don't know. They gave us an expression. What's another fact you know? They gave us this exterior.
That equals 180 degrees.
Right here?
Yep.
Yeah, unfortunately, I can't do anything inside the triangle, so I'm missing too much stuff. But if I know that's 48, I know this is 132. These are supplementary angles, right? So it's... Okay, so I don't know M yet, but I do know what the angle is. So look at this. I know to find the angle measure, I would take 180 minus 30 minus 132. And you said I get what?
18.
Are you sure it's not? Yeah, it is 18, isn't it? Okay. Now, that's not what they wanted, though. So we're taking it one step further. Do you see that?
Yeah.
They're telling us to find M. But if I know this angle is 18, then that must equal 2M plus 2. So we have to do a little algebra here. So all three angles add up to 180. I figured since I know this is 18, I'm going to set it equal, cross the line, change the sign. So I get 2M equals 16. Divide both sides by 2. We get M equals 8. So sometimes we do have a little algebra involved in it.